Hello, this is Jennifer Martinez, and in this video we're going to continue to look at quadratic equations. We're going to concentrate on solving them. What's new about this section is we're going to solve quadratic equations that cannot be factored. But let's start with exercise 1. Exercise 1 is a review of the square root property that we've seen before. And it says solve by taking square roots. So pause, see if you can do exercise 1 on your own, and then once you have completed it, continue the video to see the solution. On the right side here, I wrote the rules of what we're going to do, how to solve quadratics using square roots. So first what we're going to do is isolate the square term. So here, this x minus 3 quantity squared is the square term. So how I'm going to isolate it is I'm going to subtract 2 from both sides. I'm going to get x minus 3 squared equals 5. And then step 2, what I'm going to do is I'm going to take the square root of both sides. When you take the square root of both sides, the left side, something squared, square root, is just the inside. The right side is the square root of 5. And what I mean by this little plus or minus is you always have to add a plus or minus to one side. We saw that before. And then what we're going to do, step 3, is solve for our unknown. So I'm going to add 3 to both sides. And what I get is x is equal to 3 plus or minus the square root of 5. We solve for x, that is the answer. That is called the exact answer. You could also use your calculator to estimate the answer by taking 3 plus the square root of 5. You take 3 plus the square root of 5 on your calculator, you get about 5.236. And that is rounded. I put a little estimation here because it goes on forever, actually. So I call that the estimate. The calculator, the decimal version is the estimate. And there is another one because we also could have done 3 minus the square root of 5 on your calculator to get the second one. I rounded it to 3 places, but you could do 2 or 4, but it's 0.764 approximately. Part B. How would we isolate for the variable here? You would have to divide by 3 instead of subtracting, because that says multiplication. So this one says addition, so I subtracted. This one says multiplication, so I divide. Step 2, take the square root of both sides. The left side is just x plus 2. The right side, don't forget that little plus or minus. The square root of 4, this one actually is exact. You might as well write it when it's exact, 2. So x, if you subtract 2 from both sides, you would get x is equal to negative 2 plus or minus 2. So there's 2 answers. Negative 2 plus 2, which is 0. That's one answer. And then negative 2 minus 2, which is negative 4. Those are the 2 answers. There's no exact, there's no estimates there because square root of 4 is perfect. So try C. If you did not get the other ones, pause again. If you did, continue on. On this one, we'll just display the solution. So here is the solution. If you did it correctly, you add 4 first, take the square root of both sides, then solve for t. And this is again the exact answer, or you can use your calculator to get the estimate. So we're going to use this idea for solving quadratic equations that do not factor. So what we do to solve quadratic equations that do not factor is we do something called completing the square. We saw that a little bit in the last section. We can use the method of completing the square from section 3.3 to write any quadratic equation in the form of equations in exercise 1. Then we can solve by taking the square root of both sides. So what we're going to do here is I'm going to get rid of that 6. Because what I would like to do is make this a perfect square. So what I'm going to do is I'm going to add 6 to both sides and get a 7 here. I'm going to put a space. And I would like to make this a perfect square. In last class, we talked about the magic number. How to find a magic number. The number that you can add to make a perfect square. So what it's going to be, it's 1/2 of the b squared, where you're trying to, you're using the equation ax squared plus bx plus c. We'll just use that. We'll use the expression. So where b is that middle term. So in this case, the magic number, if we take 1/2 of the 4 and we square it, the magic number is 4. So what I'm going to do is I'm going to choose a different color and I'm going to add 4 to both sides. And then I notice the left side now factors. So let's go ahead and factor that left side. Let's change back to blue. So we get x and x, 2 and 2, multiply to 4 and add to 4. So we really do get a perfect square. So we added a magic number that made the left side a perfect square. The right side is just 11. So then you can solve by, we set it up so you can solve by using square roots, what we did before above on exercise 1. We can take the square root of the left, the square root of the right. Don't forget to add that plus or minus. And then finally, we can solve for x by subtracting that 2. You can estimate that if you want, but that right there is the solution for this equation. You do have to be careful because when there's a number in front of here, this equation with the 3 here can never be a perfect square, because remember the first here, one of them would have to be a 3x and one of them would have to be an x. Make it a perfect square, they have to be the same. So what I'm going to do first is divide everything by 3 to get rid of that term. And then what I'm going to do is get rid of the 3, just like I got rid of the 6 here, and I'm going to bring it to the other side. I'm going to leave a space for my perfect magic number. I get the same magic number as before. So again, I'm going to add, I'll do it in red, add 4 to both sides. Factor the left. It's going to be the same thing as here. The right's now going to be a 7. Take the square root of both sides. So let me just rewrite this. So you get an x plus 2 on the left. The right, don't forget that plus or minus. And then you get the answer by subtracting 2 from both sides. And that would be the answer to the second one. So let's go ahead and write down those rules. So what we did here is we first need to get rid of this 4. We need to divide by the square coefficient. So let's go ahead and do that. And I should have said one more thing. I should have added, and I added it right here, and move constant to the right. So take this -5 force and move it to the right. little less space. I think we're running out of room here. Now we're going to add the magic number to both sides. So what was the magic number again? It was 1/2. So the magic number in this case is 1/2 of the middle term. Middle term is -1. That negative doesn't matter because you square it. So it's like saying -1/2 squared, which turns out to be 1/4. I realize it's a fraction, but do not fear. It's all going to work. So I'm going to add, I'll do it in red again, a 1/2 to both sides. Let's do that in red. Where's the red? There it is. Oh, I'm sorry, 1/4. The left side is going to factor. Now, the factors of these, this is going to be x and x. This is going to be perfect squared, so it has to be this number right here. It's going to be -1/2, -1/2, because that makes 1/4, and -1/2, -1/2 do add up to -1. This is going to be 6/4. So what do we get? Almost there. So we factored the left, simplified the right. Now we're going to solve using square roots. Square root of both sides. The left side is just x minus 1/2, and whatever in the square root. Let's add a plus or minus. Square root of 6, I'm just going to leave because it's not perfect. But square root of 4 is actually 2. So the answer is, I know I'm going into this next problem, but the answer is, whoops, what is the answer? Let's erase that. Add 1/2 to both sides. It's going to be 1/2 plus or minus the square root of 6 over 2. Whew. There it is. So that was a tough one. We definitely needed more room. The next example. So now we're going to do the same exact thing. I guess I do want to make this smaller so I can see all my rules. We're going to do the same exact thing, but for A's, B's, and C's. So let's do those steps one more time. Let's divide by, and again, if you want to try to pause this and do it on your own, please do so. And then you can come back. But what we're going to do is we're going to divide by the square coefficients. So I'm going to divide everything by that A. So I did that and move the constant to the right side. I'll leave a little space so we can add the magic number to both sides. So what is the magic number? It's 1/2 the B, which in this case is B over A, and we square it. So it's going to turn out to be B squared, 2 squared is 4, and then A squared. So that's what I'm going to add to both sides. So now we did that. We're going to factor the left. To factor the left, you get an x and x for the first, and the last is going to be this inside thing. You would get b squared over 4a squared, and if you add these two, you'll see you get that middle term. Simplify the right. Well, you got to get an LCD. 4a squared is the LCD. This one is missing a 4 and an a, so I'm going to multiply top and bottom by 4a. I'm going to put the negative first. I'm going to write this as b squared minus 4ac all over 4a squared. I know it's complicated, but the left side is just x plus 2 over a squared. So now we factored the left and simplified the right. So now finally we're going to take the square root of both sides, use the square root property to solve. We're almost done. The left side is just the inside. Don't forget to add a plus or minus the right side. I'm going to subtract this over, and I'm going to come up with a formula. We can simplify this formula a little bit because we almost are there. We have the numerator you cannot simplify, but the denominator, the square root of 4a squared, is just 2a. And that, by the way, is called the quadratic formula. And that is the answer. We're going to use this in the next video.